Let's go through LeetCode 2434 using a robot to print the lexicographically smallest string. It gives us the original string S, and there is a robot. We can do two manipulations. One is that we put this as the first character to uh, medium intermediate string um, T. And we can do this in any orders. For example, we put this one here, A here, and B here. And then the second operation is that we print the last character to the paper. So that will be B. And we can do any order of this kind of transitions. So in the end, this kind of string will all be printed to the string. It asks what's the lexically smallest character we can get. So let's look at example one. So we have Z, A, right? So what we do is that we put this one into T. So let's see, this is actually, we can print the first one is put T, that is Z. And the thing is that we found this Z, after this Z, there is still some smaller character after that, right? So what we do is that we put this Z again, and, until we find, for example, A here. It doesn't have any smaller character after A. So what do we do is that we keep doing this, and until we didn't see any smaller one, right? So after doing this, we should uh, try to get the last character to our paper. So A will be here, right? So if there are multiple A's, we're keeping this A out. And also, if for example we use out of this A, if there is B somewhere here, right? And we'll say while there is no smaller, for example, if the rest are only C, we're keeping um pop this to our result here, right? So the T string is apparently a stack. And what we do is that we need to put those kind of characters to our stack, and when we are checking whether there is smaller characters left on original S. So well, right, if there is no smaller, we're doing keeping popping this result to the string S P, right? So this will be our process. Let's look at the example two. So what we do is that, for example, let's write our own example. Okay. So if we have A, C, A, B, A, B, C. Let's look at this example. How can we go through? So this is the original S, right? So these T's are stacked. So what we do is that we are going to um, push A here, right? But here, this stack, we have element A. There is no character smaller, so this will be removed. No character smaller than A in the original one, right? So um, we can pop this one to our P. Then we put C here, and there is still smaller one. Smaller character, right? So we keeping push this to the stack. So this is another A. We'll see there is no smaller one, right? So what we do is that we are doing this A pop out. And then we have a B here. And a B, after B, there is still smaller, that is A, right? We have a A here. Then we can pop up this A. And then we have another B, right? And after this B, there is no smaller character than B. So we'll write keeping popping this one no smaller. And we'll find this character no smaller, right? And then we push C here. And so we'll find this is the last one because there is no smaller after this C. So we'll pop here and pop here, right? So this stack, every time we want to pop the item, is that we check if there is any smaller character left on S, right? So if there is no smaller, we'll use while loop to pop it and print and pop that to our string P. So that will be our process. So let's write code for this to simulate the process. So what we want is in n equals s dot let's have change this one to char array uh equals s to char array and int n equals array dot length. So how can we check if there is any smaller character left on S? We can pre-compute the minimal character to the right of each position. So we can have char call min right min equals new char and right. So what we do is that um, so we know this char right min n minus one equals array n minus one, right? So we'll say for int I equals n minus two, I greater equal to zero, I minus, we're going to have right min I equals so we need to come to char mass dot min array I and the right min I plus one, right? And then what we do is that we use a string builder for the paper, right? So this will be the result because new string builder, and we need a stack, right? So we use the cherry to simulate the stack, or this is T, whatever. This stack is T. Um, so and for this stack, we need an index. So then what we do is that for int I equals to zero, I smaller than n, I plus plus, right? So for every character, we need to push that to stack first. Will be array I, right? Then what we do is that while this stack is not empty, and we'll say um we'll say if there is on its right there is any mean um character, right? If on its right, there is no mean cap. It's for example at I, right? If this is on the stack, the stack top that is the smallest, that is at the right I minus one, right? Mean are always greater than stack top, right? Or we are at an index, the last index I equals a minus one, right? So we are in all of these cases, we are going to pop those items from the stack and append to our stream builder. So what we write is that while this one and another condition is I equals n minus one, or stack ID is smaller equal to right me I plus one. In all of these cases, we're going to pop our character from the stack. So we'll have string builder append stack. So we'll have the ID, right? And then we should move one index. So this will pop them out. And in the end, just return the string builder to string, right? Write mean. It will be ON time complexity and ON space complexity. We can also convert this to write this Python version for this. So um, we are going to have n equals length s, right? So what we do is that we need the mean mean equals so this will be a char, right? Multiplied by n. So let's say right mean n minus one will be array n minus one, right? So we can use minus one, right? Because the pattern is the same thing. So what do we do is that for I in range n minus two to minus one. So we're going to have right mean I equals mean um, array I and mean right mean I plus one, right? So what do we do? We need a stack and result. So stack result equals this and this. Um, then then we need a um, what to do is that for I in 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 range and right, let's say let's have stack dot append array I. So now what we do is that while this stack is not empty, and for example, if I equals a minus one, right? Or let's see this stack the peak the item, right, is smaller equal to um right me I plus one. In these two cases, we're going to pop the result. So pop the top and append to result pop, right? So in the end, just need to return um join results. Right? This is S returning